discuss about atoms, right? We all know that I'll not spend much time on synapses. We'll go into the numericals part, right? So because we need to cover 3 sessions again today, 3 modules, atoms, nuclei and semiconductors. Second PU will be completed today. So next we'll be starting with the first PU, right? So atoms, so when we discuss about atoms or when we talk about atoms, we all know that atom consists of a positively charged nucleus at the center, which consists of protons and neutrons, and electrons revolve around the nucleus, right? In the volume 1, we discussed about the properties of electron, right? What is electron all about? So if it is stationary, what all it does, what all the causes of if the charge is stationary, so what all effects it has, right? If the charge is moving, that is electromagnetism, moving charges and magnetism. So we studied about electron. Now we study about the atoms, means which is basically electrons also we study, plus apart from that we also study about the nucleus in the next chapter. So in this chapter we study about how the electrons are distributed in an atom. We have various models for atom, how the atom is, right? So models, one is called Rutherford's model, you already studied, right? So by his scattering of alpha ray scattering experiment, so he has given approximate size of the nucleus, it's about 10 to the power minus 15 meter or Fermi, 1 Fermi, right? And he predicted that there is a positively charged nucleus. I mean there is some positively charged one at the center, right? So later on after that, so previously we had something called plum pudding model, which was discarded, like it's like something similar to plums in watermelon. So that's model was discarded. Now later on the scientist by name physicist Niels Bohr, right? So he suggested a model of atom, so wherein the electrons are revolving around the nucleus. So Rutherford also suggested this, but he couldn't give complete picture of how the electrons are. Okay. So during using his Bohr's postulates, so he explained how the electrons are in the are revolving around the nucleus in stationary orbits, right? We all know about Bohr's postulates. So Bohr's postulates will tell us how the electrons are revolving around the nucleus, and talks about angular momentum, and it talks about the if at all there is jump or the electrons, okay, transition of electrons from one orbit to other orbit. So when it goes to lower orbit to higher orbit, it absorbs energy, and when it comes from higher orbit to lower orbit, it emits energy, right? So in this thing, so mainly we discuss about, so when we talk about one is about the models of atom, the concepts related to Bohr's atom model, and why Rutherford's model atom model was failed, and Bohr's model, what was the merits and demerits of it. And I think there are other models also. There is something called relativistic model, okay, which is not part of your syllabus, right? So these are the 2 models we discuss about. Okay, one is called the Rutherford's model and Niels Bohr's model. Okay, and so you should be familiar the wavelength of the emitted radiation. So when a transition takes place, so this is nothing but wave number, right? Wave number is equal to 1 by lambda. So R is equal to, 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. So n1 is the lower orbit, n2 is the higher orbit. Okay. So this is about the wave number. So depending on the transition, from where it is transition taking place, is it from first orbit, like basically n1 could be 1, n2 could be 2, 3, etc., 2, 3, 4, etc., or n1 could be 2 and n2 could be 3, 4, 5, like that. Okay. So depending on the transition, so we have the wave number, we have the wavelength, right? And if there is a transmission, or if there is a transition from one orbit to other orbit, means E2 minus E1. So normally when transition takes place from lower orbit to higher orbit, it absorbs energy, right? When it transition takes place from higher orbit to lower orbit, the same amount of energy is released, right? So E2 minus E1 is equal to what? H nu, that is equal to, we have an equation, minus 13.6 into 1 by n1 squared minus 1 by n2 squared, right. So these are the equations which we are going to discuss, right. Just remember these equations, and you should be knowing Lyman series, Balmer series, Paschen series, bracket series, Affand series. So what are these are concept based question. I will not go in detail about it. And apart from that, we have the expression for energy. What is the expression for energy? Energy of an electron. No, there is an expression, m e to the power of 4, mz square e to the power of 4, 8 epsilon naught square n square h squared, right. So that is the energy of an electron, in the nth orbit. And what about radius? Epsilon naught n square h squared by pi m z e squared, right. So that is the radius of the orbit of the electron, right. So these things, with this idea about atoms, so we'll see the questions, okay, how the questions are, okay. It's mostly what we have done is, instead of selecting questions from the book, what we have done is we have compiled all the questions from the previous exams, NEET and CET, so that you have a rough idea about the questions that will be asked in the examination, okay. So we'll run through the questions now. Okay, right. Right, first question. You all have the question paper with you? You all have the paper now? Okay, next. So it's about alpha particle scattering and Rutherford's nuclear model of atom. The first question is, when an alpha particle of mass m moving to velocity v bombards on a heavy nucleus of charge Z, its distance of closest approach from the nucleus depends on m as. You all know that what is distance of closest approach? So no, what is distance of closest approach? Center of the nucleus it returns, right. Distance of closest approach means, suppose this is the nucleus, the positively charged nucleus. Now alpha particle is traveling in this direction, right, it travels. So when it travels, it has a kinetic energy now of mv squared. When it travels, it has a kinetic energy. So, and at which the particle returns to its, so at this point it stops, okay. This is called distance of closest approach. When an alpha particle travels with some kinetic energy, so you project it with some kinetic energy, you accelerate it, so that kinetic energy is equal to half mv squared. So when it gets accelerated, now because of the repulsion, now this is alpha particle is positive, alpha particle is positive. What is the charge of alpha particle? Plus 2, right. Now this is also plus, so therefore plus 2e, alpha particle is plus 2e. So here what happens, because of repulsion, it returns to its back. So at this point the velocity becomes 0, which means that the entire kinetic energy gets converted into potential energy. Kinetic energy becomes potential energy. Now here the question is, what is the question, right? Its distance of closest approach from the nucleus depends on, okay, depends on m as. So we know this of mv squared. So kinetic energy becomes potential energy. So it is 1 by 4 pi epsilon naught Ze into 2e, correct now? Ze is this is Ze by, so 2 Ze squared, correct now? So 2 Ze squared divided by distance is r, I can call it as r or d, right? So depends on here the distance of closest of when an alpha particle of mass m moving to velocity v bombards on a heavy nucleus of charge Z, its distance of closest approach from the nucleus depends on m as, okay. If you have a different particle other than alpha particle, how does distance of closest approach depend on mass? As you can see, this is constant, okay, this is also constant, initial velocity is constant, Z squared is constant, but they are asking how does d depends on m. So d is inversely proportional to m. So d take this side, m this side. So d is inversely proportional to m. So option number C. Okay, now second question. Understood? So D is inversely proportional to M. Next question, an alpha nucleus of energy of mv squared. I think it's very similar question, but they have put it in a different way. Question is different, but the answer is same. An alpha nucleus of energy of mv squared. So they are given of mv squared bombards heavy nuclear target of charge Ze. It bombards a nuclear target of charge Ze. Then the distance of closest approach for the alpha nucleus will be proportional to 1 by m. So question is different. They have put it in a different. Answer is same. It is 1 by option C. Yeah. Next one, question number 3. Question number 3. In a Rutherford scattering experiment, when a projectile of charge Z1, when a projectile means alpha particle. Here projectile means alpha particle. So in a Rutherford scattering experiment, when a projectile of charge Z1 and mass m1, the mass of the alpha particle is m1, charge is Z1, approaches a target of nucleus of charge Z2. Here charge is Z2, here charge is Z1. So in place of alpha particle, what we have? A particle with Z1 and mass is capital M, and this is mass m1, target nucleus of Z2 and mass m2. Okay, mass m2. The distance of closest approach is r0. So here the distance of closest approach is r0. So what we can write here of, okay, it is m1. Okay, so they are not given velocity. We'll assume it as v squared. We'll take it as v squared, and here the nucleus is charge is Z2e, right? Mass is m2, right? The distance of closest approach is r0. The energy of the projectile is, what is the energy of the projectile? We are talking about this energy, right? So this is equal to of m1 v squared is equal to 1 by 4 pi epsilon naught Z1 Z2 e squared by r0. Okay, so the energy of the projectile is directly proportional to, this is the energy na, it's proportional to, does it proportional to, so as you can see this is left hand side of mv1 v squared. This is the energy of the particle, correct? ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಹಿಂದ್ಗಡೆ ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? Okay, of m1 v squared is the energy of the projectile. Projectile ಅಂದ್ರೆ alpha particle ಅಂತ ಇಲ್ಲಿ. So of m1 v squared is proportional to, because E is a constant na, and r0 is a constant, right? Now it is proportional to Z1 Z2. So proportional to Z1 Z2. So therefore option number A. Yeah. Next, question number 4. Fourth question, an electron is moving around the nucleus of a hydrogen atom in a circular orbit of radius r. The Coulomb force P between the two is, electron is moving around the nucleus of a hydrogen atom in a circular orbit of radius r. The Coulomb force P between the two is, what is the Coulomb force formula? 1 by Q2 by r square. So but here we have to consider the direction. Option C. K E squared by r cube into root vector. Okay, this is K, right? And here, so because hydrogen has how much charge? 1. It has 1 proton, right? And electron, you are talking about electron, 1 electron. So therefore Q1 Q2 is E squared and R square. So because, so they are given R cube na, so vector R. Wait, I'll tell you. So here, why not? A, K E squared R square. Illenaಗಿದೆ unit vector ಕೊಟ್ಟಿದ್ದಾರೆ, but it is minus. It attractive force na. No, it is not plus. Why? I'll tell you. Listen. See, so if its force is attractive, we'll have to take it as negative. force is attractive. Okay, force is attractive, we'll have to take negative. Okay, if it's repulsion, plus. But ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, they have not said magnitude of the force, they have said coulomb force ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಅದಕ್ಕೆ ಯಾವಾಗ ಫೋರ್ಸ್ ಅಟ್ರಾಕ್ಟಿವ್ ಇರುತ್ತೋ, ಓಕೆ, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ, ಸೊ ಫೋರ್ಸ್ ಇಸ್ ಅಟ್ರಾಕ್ಟಿವ್ ಅಲ್ವಾ. ಸೊ ಇಫ್ ದ ಫೋರ್ಸ್ ಇಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ, ಪ್ಲಸ್ ಸಿ ಮೈನಸ್ ಸಿ ಆಗುತ್ತೆ, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಇಸ್ ನೆಗೆಟಿವ್, therefore force is attractive. When its force is attractive, we'll have to take it as negative. So k e squared ಇಲ್ಲಿ r ಕ್ಯೂಬ್ ಬಂದಾಗ ಇದು ವೆಕ್ಟರ್ r ಆಗುತ್ತೆ. ಅರ್ಥದ ಅಕಸ್ಮಾತ್ ಇಲ್ಲಾಂದ್ರೆ ಈ ಆಪ್ಷನ್ ಇಲ್ಲ, ಅದು ಇಸ್ ಆಲ್ಸೋ ಕರೆಕ್ಟ್. k e squared by r squared into vector r, this also correct answer. ಬಟ್ ಇದು ಆಪ್ಷನ್ ಇಲ್ಲಿ ಇಲ್ಲ ಅಲ್ವಾ, ನಮ್ಗಿರೋದು ಇದೆ r ಕ್ಯೂಬ್ ಇದೆ, ಯೂನಿಟ್ ವೆಕ್ಟರ್ r ಇದೆ. ಸೊ ಅದರಿಂದ ಈ ಆಪ್ಷನ್ ಇದ್ರೆ ಈ ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಆರ್ ಯು ಕ್ಲಿಯರ್? ಈ ಆಪ್ಷನ್ ಇದ್ದಿದ್ರೆ ಇದು ಕರೆಕ್ಟ್ ಆಗ್ತಿತ್ತು, ಬಟ್ ಈ ಆಪ್ಷನ್ ಇಲ್ಲ ಅಲ್ಲಿ. ಅದರಿಂದ ನಾವೇನು ಮಾಡಬೇಕು, ಯೂನಿಟ್ ವೆಕ್ಟರ್ r ಬಂದಾಗ ಇಲ್ಲೇನಾಗುತ್ತೆ, r ಕ್ಯೂಬ್ ಆಗುತ್ತೆ. ಅದು ಗೊತ್ತಿದೆಯಲ್ವಾ ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ. ಇಫ್ ಇಟ್ ಇಸ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್ r, ದಿಸ್ ಬಿಕಮ್ಸ್ r ಕ್ಯೂಬ್. ಸರಿ, ವೆಕ್ಟರ್ r ಬಂದರೆ ಯೂನಿಟ್ r ಕ್ಯೂಬ್ ಆಗುತ್ತೆ, ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಬಂದಾಗ r ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಆರ್ ಯು ಕ್ಲಿಯರ್? ಓಕೆ, ಸೊ therefore ಆಪ್ಷನ್ ನಂಬರ್ option D. Option D is the correct answer. Next question. So next question is about atomic spectra. Spectra, atomic spectra. The ratio of wavelengths of the last line of Balmer series. The last line of Balmer series and the last line of Riemann series. Last line, the ratio of wavelengths. So we know 1 by lambda is equal to r into 1 by n1 squared minus 1 by n2 squared. Last line of Lyman series. So for last line of Lyman series, if I take Lyman series, so n1 is what? 1, n2 is infinity. So therefore it is 1 by lambda L. I call it as lambda L. This is r into 1 by 1 squared. Correct now? 1 by n2 square is 1 by infinity. Anything by infinity is 0. Right? Therefore here, so we get lambda L is equal to 1 by r. Correct? Correct now? Lambda L I have taken 1 by r now. Correct, right? Next, similarly for Balmer series. So for Balmer series, so 1 by lambda Balmer series is r 1 by n1 is what? So correct, n1 is equal to 2, n2 is infinity. So therefore 2 square by infinity squared. So what do we get? I write directly lambda b is equal to 4 by r, right? Lambda b is equal to 4 by r. Correct ido? Correct? So therefore lambda L by lambda b 4 is to 1. So the lambda L by lambda b is, because 4 by r, what we get? 1 by r, lambda L by lambda b na. Oh, Balmer series, okay, right, it's Balmer series, correct. So Balmer series means, so it is 4 by, you get 4 by r by 1 by r, so r gets cancelled, we are left with 4. Value of Rydberg constant is 10 to the power of 7 per meter cube. So Rydberg constant is 10 to the power of 7 per meter cube. Are you still writing? Balmer series, can we write directly here? So last line of Balmer series is lambda b, so which is basically r into 1 by 2 square minus 1 by infinity squared. So they are asking wave number na. Wave number is reciprocal of wavelength. Understood? Wave number is the reciprocal of wavelength, right? Wave number is nu bar is equal to 1 by lambda b, that is equal to r into 1 by 2 square minus 1 by infinity squared. So therefore wave number is 10 to the power of 7, right, into 4, correct now? So 1 by 4 is how much? 0.25, 10 to the power of 7. So many number of wave numbers, so many more waves, right, in case of Balmer series. The last line of Balmer series, when the transition takes from infinity to the second state, that is called Balmer series. So the number of spectral lines present in this will be equal to this much, right. So therefore answer is A, option number A. So we'll go to the next question. So ratio of longest wavelength corresponding to Lyman and Balmer series. Huh? Option C. Okay. Marna, ratio of longest wavelength corresponding to Lyman and Balmer series in hydrogen atom. So wavelength 1 by lambda is equal to R into 1 by 1. Correct na? Lyman series longest wavelength is N1 is 1, N2 is infinity. N1 is 1, lambda L, N1 is 1 and N2 is infinity. Therefore, lambda L is equal to 1 by R. I think I have done this problem similarly. Okay, and Balmer series N1 is 2, N2 is infinity. So 1 by lambda Balmer series is R by 1 by 2 squared minus 1 by infinity squared. So we can write lambda B is equal to 4 by R. Correct now? So therefore what do we get? Longest wavelengths corresponding to longest wavelength is N1 is 1, N2 is infinity. Huh? Okay, longest wavelengths corresponding to, so that's the first transition, na? Like what you have done. Okay, correct. So basically this one, take it as 2 minus 1 by 2 squared, that is shortest wavelength. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಅದು ಫಸ್ಟ್ ಕ್ವಶನ್ ಬಂದು ಲಾಸ್ಟ್ ಲೈನ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಲಾಂಗೆಸ್ಟ್ ವೇವ್ಲೆಂತ್ ಅಂದರೆ N1 is 1, N2 is 2. ಶಾರ್ಟೆಸ್ಟ್ ವೇವ್ಲೆಂತ್ ಏನಾಗುತ್ತೆ? N1 is 1, N2 is infinity ಆಗುತ್ತೆ. Okay, this is N2 is 3. So therefore this becomes 1 by lambda L is equal to 1 by R 1 minus 4, which is 3 by 4 R. Correct? And here it is 1 by 3 squared. Okay, so this will be R into 1 by 4 minus 1 by 9, right? So this will be 1 by lambda B. So therefore my lambda B is equal to R into 36 9 minus 4, correct na? So which is 5 by 36 R. So therefore Lyman and Balmer series they are asking. Okay, corresponding to Lyman and Balmer series. So if I divide this, it will come to new denominator. So what I do is, I do this 1 by lambda B by 1 by lambda L. 1 by lambda B is 5 by 36 R and this one is 3 by 4 R. Okay, this goes up 4 9s are. Okay, so 3, okay, it is 5 by 27. So lambda L by lambda Balmer. This goes to numerator, this comes to denominator. So therefore it is 5 by 27. Longest wavelength is the longest wavelength, right? So the first question was about last line of Balmer. Infinity, N2 is infinity. N2 is infinity. Both the cases N2 is infinity. So for example, if they ask for Paschen series, Lyman Balmer Paschen series, N1 is 3, N2 is 4. Arada, N2 is 4. Bracket series, ಅದು ಗೊತ್ತಿರಲಿ. ಅದು ಯಾಕೆಂದರೆ ಕ್ವಶನ್ ಹಿಂಗೆ ಕೇಳುವಂತ ಆಗೋದಿಲ್ಲ, ಅದು ಚೇಂಜ್ ಆಗ್ಬೋದು. ದೇ ಮೈಟ್ ಆಸ್ಕ್ ಅಬೌಟ್ ಅದರ್ ಸೀರೀಸ್ ಆಲ್ಸೋ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಓವರ್. Bohr model of hydrogen atom. For which of the following Bohr model is not valid? Option D. Because Bohr's atom model is applicable for hydrogen and hydrogen-like atoms. Hydrogen-like atoms means where which has one proton, one electron. Z is 1, correct na? So hydrogen-like atoms. So therefore here, so singly ionized helium atom, it has one proton because one electron has been removed. So it's similar to hydrogen. So and deuteron atom also same thing. It has deuteron is 1H1, correct no? Deuterium is atom. Deuteron is a particle. Arada? Deuteron is a particle. Deuterium is an atom. Are you clear? So deuterium, if you take, it has one proton and one neutron, one electron. Correct na? Deuterium. Deuteron is one proton, one electron. Okay. Deuteron. Okay. Next one. Okay. So therefore answer is singly ionized neon atom. What is the atomic number of neon? 10. Okay, right. So Z is 10. So that is not equivalent of hydrogen atom. Next one. Next question. The total energy of an electron in an atom in an orbit is, total energy is, okay. So I need to go little slow, right. Ninth question. Question number 9. The total energy of electron in an atom in an orbit is minus 3.4 electron volt. This is the total energy. So what is total energy means? When I say total energy of an electron, what does it mean? What all it has? What all types of energy it has? Kinetic and potential energy. So kinetic and potential energy. So as you can see here, you might also be knowing one more equation. Total energy or magnitude of total energy is equal to kinetic energy, correct? The magnitude, because the total energy is negative. Potential energy plus kinetic energy. Artha telido? Total energy is negative. Potential energy due to electrostatic force between the electron and the nucleus. So potential energy, and electron is revolving, that's kinetic energy. The total energy is negative, it's bound to the nucleus. Artha telido? Negative antandre, it is bound to the nucleus. Force is attractive. So negative energy. So total energy, the magnitude of total energy is equal to kinetic energy, which is equal to potential energy by 2. Right? Because potential energy is equal to twice kinetic energy. Artha aithe helidu? Potential energy is equal to twice kinetic energy. So here the question is, the total energy of electron is minus 3.4 electron volt. Its kinetic and potential energies. As you can see here, total energy is given minus 3.4. Now the magnitude of total energy is equal to kinetic energy. So then what is the kinetic energy? 3.4 electron volt. It's positive. Magnitude. Kinetic energy is positive. It can never be negative. And what about potential energy? Potential energy is twice kinetic energy. Correct na? So therefore it is, but it's negative. Since it is bound to the nucleus, it is negative. It's bound to the nucleus. Force is attractive. When it is bound to the nucleus, it is negative. Minus twice kinetic energy, it is minus twice 3.4 electron volt, which is 6.8 electron volt. Understood? So option D. Option D. Okay, so we'll go to next question. Okay, I think we'll skip 10th question. There is data is little missing in that. 10th question, we'll skip the 10th question. We'll go to 11th question. 11th question. Okay, 11th question. Question number 11. The ratio of kinetic energy to the total energy of an electron in a Bohr orbit of hydrogen atom is, the ratio of kinetic energy to total energy of electron in a Bohr orbit of hydrogen atom is? I think its answer is there. We know that kinetic energy is equal to total energy, na? Kinetic energy is equal to total energy, but total energy is negative, right? Kinetic energy is equal to total energy, but it is equal to magnitude. So therefore, what we write, total energy is always negative. So therefore, kinetic energy is positive, which is equal to total energy magnitude. Therefore, 1 is to minus 1. 1 is to minus 1. Option number B. Yeah. Next, question number 12. Question number 12. Consider, ಅರ್ಥ ಆಯ್ತಾ ಇದು ಇಲ್ಲಿವರೆಗೂ? ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? Any doubts so far? Anybody the doubt? Okay, next question. Consider third orbit of helium plus using non-relativistic approach. Okay, andre there is something called relativistic model anta, so that we are not going to discuss. We have, so here non-relativistic approach, the speed of electron in this orbit will be what is the speed of electron? So this is a standard formula. Velocity of the electron is given by 2.19 into 10 to the power 6 into z by n. Are you familiar with this? So this is a standard formula. Velocity of the electron is given by in any orbit and whatever the z, right? Depending on z and depending on n, the velocity of the electron changes. So the equation is given by, the expression for that is 2.19 into 10 to the power 6 z by n. So they have asked for helium plus ion. What is z of helium plus? 2. So therefore it is 2.19 into 10 to the power 6, z is 2 and n is third orbit, correct now? So therefore it is 8, okay, 3 and 4 divided by 3. So which is 1.4, okay, yeah, 1.46 into 10 to the power 6. Velocity is meter per second. So therefore, option number D, yeah, 1.46 10 to the power 6 meter per second. For velocity of electron. Okay. Next question. Aita baradiradna. Okay. Next question. So an electron in hydrogen atom makes a transition from N1 to N2. Transition N1 to N2, where N1 and N2 are principal quantum numbers of the two states. Assuming Bohr's model to be valid, the time period of electron in the initial state is 8 times that in the final state. The possible values of N1 and N2. So they have given the time period of electron in the initial state. So T1 is 8 times T2, right? So the time period of electron means, you know what is time period? Time taken to go around the nucleus, that's called time period. So time period in the first orbit, right, sorry, not first orbit, N1 state. This is N1 state and this is N2 state, right? So it goes from N1 to N2 state. So the time period of electron in the N1 state means, so N1 state, it could be any number. So it is 8 times the time period in the N2 state, right? So with this data, so we'll have to find out what is N1 and N2. So we know this, the period is proportional to n cube. Gotalva? So ಆದಷ್ಟು ಇದನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. The period is frequency ಕೇಳಿದ್ರೆ 1 by f ಆಗುತ್ತೆ. So period is directly proportional to n cube. Correct now? So with this data we can calculate, so what is the n1 and n2. So here therefore T1 by T2 is equal to n1 cube by n2 cube. Baribada? Okay, or we can take so T1 is 8 T2, correct? And this is T2, this is n1 cube by n2 cube. Okay, T2 gets cancelled. Now what we do here is n1 by n2, we'll take cube root of this, cube root ತಗೊಂಡಾಗ, so ಇದೇನಾಗುತ್ತೆ 2 by 1 ಆಗುತ್ತೆ, because cube root of 8 under 2 cube. 8 can be written as 2 cube. Correct? 8 can be written as 2 cube. So cube root of 2 cube is nothing but 2. Okay, ಇದನ್ನ cube root ತಗೊಂಡಾಗ cube root ಅಂತ ಗೊತ್ತಲ್ವಾ? Okay, cube root of 8, it's 1 by is 2 ಆಗುತ್ತೆ. So therefore, so how are they related? N1 and N2? So N1 is 2 N2. Correct? So if N2 is 1, N1 is 2. Right? And if N2 is 2, N1 is 4. Are you clear? If N1 is option D ಆಗುತ್ತೆ, because 1 and 2 ಕೊಟ್ಟಿಲ್ಲ ಇಲ್ಲಿ, 1 and 2 ಕೊಟ್ಟಿಲ್ಲ. ಈಗ N2 1 ಅಂತ ಕೊಟ್ಟಿದ್ರೆ N1 ಏನಾಗ್ತಿತ್ತು? 2 ಆಗ್ತಿತ್ತು. ಅರ್ಥ ಹೇಳಿದ್ದು? N2 1 ಆಗಿದ್ದಿದ್ರೆ N1 2 ಆಗ್ತಿತ್ತು. ಬಟ್ ಆಪ್ಷನ್ ಕೊಟ್ಟಿಲ್ಲ ನಮ್ಗೆ ಇಲ್ಲಿ. ಇದೇನು ಕೊಟ್ಟಿದ್ದಾರೆ? N2 is 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, N1 is 4 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So that's the correct option. So if N2, if I put it 2 here, N1 becomes 4 na. But all other options are wrong. So because 1 is to 4 ಬರ್ತಾ ಇದೆ, 1 is to 8 ಬರ್ತಾ ಇದೆ, and other one is I think 1 is to 3 ಬರ್ತಾ ಇದೆ. First option is 1 is to 3 na. Correct na? First option is 1 is to 3 or 3 is to 1, 3 is to 1, and second one is 4 is to 1. And how about the third one? Sorry, second is 8 is to 1. Second is 8 is to 1, and third one is 4 is to 1, and last one is 2 is to 1. So therefore that is the correct answer. Option number D. Artha aida? Okay. Tumma simple ಆಗಿರುತ್ತೆ. You just have to remember, I'm telling you, CET, these are standard CET questions. Just have to know the formula and concept. That's very important concept. So it's about period, time period, and if you can just write down these shortcuts, period is directly proportional n cube, and even energy. Okay, energy bandre, energy, how it is directly proportional? Is it directly proportional or inversely proportional? Inversely proportional. Question number 14. 14th question. Okay, monochromatic radiation emitted when electron on when electron on a hydrogen atom jumps from first excited to the ground state, irradiates a photosensitive material. The stopping potential is measured to be 3.57 volt. Stopping potential is V0, it is 3.57 volt. So if the stopping potential of the photoelectron is 10, next question it is. Okay, the threshold frequency of the material. What is threshold frequency? Are the question ido? Something related to your dual nature, photoelectric effect. ಅದು ಆಕ್ಚುಲಿ ಆ ಕಾನ್ಸೆಪ್ಟ್ನ ಇಲ್ಲಿ ತೊಗೊಂಡಿದ್ದಾರೆ. ಅರ್ಥ ಆಯ್ತಾ? ಇದರಲ್ಲಿ ಯು ವುಡ್ ಹ್ಯಾವ್ ಸೀನ್ photoelectric effect ಅಲ್ಲಿ when light is made to incident on cathode, it emits electrons, right? So if the energy is greater than the threshold or work function of the metal, then the electron will have kinetic energy, that is equal to stopping potential. Correct now? So that is the concept here used. So here an electron, monochromatic radiation emitted when electron on a hydrogen atom jumps from first excited state to the ground state, means E2 minus E1. Correct now? First excited state to the ground state, irradiates photosensitive material. The stopping potential measured to be 3.57 volt. The threshold frequency. Right. So it is E2 minus E1 is what? Minus 13.6 na into 1 by N1 square minus 1 by N2 square. Correct? Energy emitted by electron. So when a transition takes place from higher energy state to the lower energy state, second state to the ground state is taken as 1, first excited state, that is equal to N2, it is equal to 2. Absorption, emission ಎರಡಕ್ಕೂ ಇದೇ equation ಆಗುತ್ತೆ. ಅರ್ಥಾಯ್ತಾ? ಎರಡು ಕೇಸಲ್ಲಿ ಇದೇ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ? So this is minus 13.6, 1 by N1 square. First state is 1, second state is 2 square. Correct na? Correct?
Yes sir.
Right. It's minus 13.6, 1, right? 1 by 4, which is minus 13.6 into 3 by 4. Correct? So minus 3 by 4. No. Minus 3. Okay. Right. This actually minus barbad idu. Okay. Now one kelsa marana. Ee tara marana. We'll do this way. Right. What we do is E2 is energy corresponding to the first one is minus 13.6 by N2 squared, and E1 is minus 13.6 by N1 squared. Correct. So it is minus 13.6 by N2 square and raised to 2 square, which is 2 square alva 4. 4 minus 13.6 by 4, which is 1.2 electron volt. Correct? Correct enrappa? Oh, sorry, 3 point. Not more than 3.1. Correct na? Wait. Minus 3.1 electron volt. Now, what about E1? E1 is minus 13.6. Correct? Oh, okay. Right. So 3.4 electron volt. So E1 is this, E2 is this. Now it is basically the difference. It is basically E2 minus E1. Correct? E2 minus E1. So minus 3.4 minus of minus 13.6. It is 9.2 now. Correct? 9.2. Correct? 9.2 electron volt. Minus 3.4 minus of minus plus 13.6. When you subtract this, you get 9.2 electron volt. All clear? So the energy is 9.2 electron volt. What is this?
10.2, sir. That is 10.2.
So 10.2 electron volt. Correct? Okay. Now this is the energy emitted by electron. Isn't here? This is the energy emitted by electron, and this energy is made to incident on the metal. This energy is made to incident on metal. So this is the energy emitted by electron when transition takes place from higher energy state to the ground state. Now this energy is made to incident on the metal. This is the monochromatic radiation. This energy is made to incident on the metal. So we know Einstein's equation H mu is equal to H naught plus EV naught. Correct now? Electron volt. Correct?
Yes, sir.
Nothing but this is nothing but kinetic energy for stopping potential. H2 is how much? 10.2 electron volt. Correct now? Right. H2 naught plus EV naught. EV naught is how much? 3.57 electron volt. Right? Artha aita?
Yes, sir.
Have doubt idea idu?
No, sir.
Okay. Now therefore H2 naught is equal to 10.2 minus 3.5. ಎಷ್ಟಾಗುತ್ತಿದು 10.2 minus 3.5. Calculator use ಮಾಡಿ. Don't use calculator. Okay. 12 minus 5 is 7 na? 6.7 electron volt. Correct? Now wait. Question here is you have to find out threshold frequency. So threshold frequency is U naught is equal to 6.7 divided by what is H value? 6.625 into mass 32. This is an electron volt. You have to convert into joules. What ಮಾಡ್ತೀರಾ ಅದಕ್ಕೆ? Multiply by 1.6 into 10 power minus 9. Will you simplify now? Simplify ಮಾಡಿ. So ಇದನ್ನ ಏನು ಮಾಡಬಹುದು ಅಂದ್ರೆ 6.7 ಇದೆಲ್ಲ 6.625 cancel this. So 1.6 ಮೇಲೆ ತಗೊಳ್ಳಿ minus 13 is 15. 1.6 into 10 power 15 option number C. ಮಾಡಬೇಕು ಏನಂತೆ 50 ಓಕೆ 45 ನ್ಯೂಮರಿಕಲ್ಸ್ ತಗೊಳ್ಳಿ ಅಥವಾ 60 ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಓಕೆ everything will not be cake walk for you. ಅದದ cake walk ಅಂದ್ರೆ ಗೊತ್ತಲ್ವಾ
Sir, 1 minute ಅಲ್ಲಿ exam ಅಲ್ಲಿ ಇಷ್ಟೊಂದೆಲ್ಲ
ಇಲ್ಲ ಏನಂದ್ರೆ I will tell you one second 75 questions ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ out of 75 questions out of 75 sorry 60 questions
60 questions, sir.
you have 75 minutes
Yes, sir.
60 questions ಅಲ್ಲಿ 75 minutes ಅಲ್ಲಿ 60 questions ಮಾಡಬೇಕಾಗುತ್ತೆ ಅದರಲ್ಲಿ ಏನಾಗುತ್ತೆ roughly 40 to 45 questions it will be like easier one not this easier one like previously what we have done like we have used shortcuts like period is proportional to okay n cube or radius is proportional to n squared ಆ ತರ numerical sir so provided if you are thorough with shortcuts ಅದನ್ನ like stopping the first piece ತಗೊಂಡಾಗ stopping distance is directly proportional to initial speed square of the speed so there are some shortcuts like for 40 questions you can do that way but remaining definitely it will be there okay ನೀವು 60 questions ಅಲ್ಲಿ ಈ ತರ ಒಂದು 15 question ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತೀರಾ ಸೊ ಅಲ್ಲಿ ಏನು ಟೈಮ್ ಸ್ಪೆಂಡ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಐ ಮೀನ್ ಟೈಮ್ ಸೇವ್ ಮಾಡ್ತೀರಾ ಆ ಟೈಮ್ ಲೈಕ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 75 ಮಿನಿಟ್ಸ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ 75 ಮಿನಿಟ್ಸ್ ಅಲ್ಲಿ ಒಂದು 30 to 45 questions okay you will do it in 30 seconds some you can do it 5 seconds looking at the question you can directly answer 5 seconds 10 seconds but rest of the questions